What is on Maths World? We are back again talking about inverse trigonometric functions. And the topic for this video is going to be the inverse of the tangent function. Okay? So, the best way to start this is let's look at a picture here, the tangent of x. So this is f of x equals tangent x. Okay? And again, this function is not one-to-one, so to make it an invertible function, we have to restrict it to a domain. And if you want to get in more detail about that, make sure you watch the previous two videos about sine and cosine. I'm just going to jump right to it on this one. That is, to make this function one-to-one, we're going to restrict it to the domain inside here. Restrict it to this domain. So as we forget about, when we think of the tangent of x as an invertible function, we forget about everything here and everything there and simply think of it as this function here restricted to this domain between negative pi over 2 and pi over 2. Okay? But it's important to note here that the domain of f is going to be the open interval negative pi over 2 to pi over 2, because recall that at negative pi over 2 and pi over 2 our function is a vertical line which doesn't have a slope, and the tangent is the slope of the radius when we look at the sketch an angle in the unit circle. So let's jump right to it here. So for t and r, the arctan of t denoted inverse tangent of t. So let's do the inverse tangent of, let's say, 0. Okay? So the inverse tangent of t is the unique angle in negative pi over 2 to pi over 2. So we need some theta whose tangent equals t. So we need some theta between negative pi over 2 and pi over 2. So we need the tangent of theta to equal 0. Okay? And if we look at the unit circle, let's just draw a quick circle here. And we are between negative pi over 2 and pi over 2. Just like for the arc sine, we want to know, where is the slope 0? Okay? If I just start drawing in some slopes here, when is my slope 0? Okay? It's like about right there. Okay? Here my slope is negative, getting big in the negative direction. Here it was positive, big in the positive direction, getting smaller, until right here the slope is 0. So that is going to be at inverse tangent of 0 equals 0. Okay, what about the inverse tangent? Inverse tangent of, what do we have? Root 3 over 3? Okay, or we can think of it as the, I like thinking of it as the arc tangent of root 3 over 3. These mean the same thing. Okay, so first of all, let's draw a circle. Okay, and know that the arc tangent is going to put me over here when I'm talking about the inverse function. And when is it going to be a positive root 3 over 3? Okay, so I believe at pi over 6 we have root 3 over 3, I believe, yeah, and at 45 we have the inverse, that the slope is 1, and at pi over 3 we have that the slope is root 3. Let's make sure here. I think the answer is going to be pi over 6, but let's do the work. So when theta equals pi over 6, we have what, over root 3 over 2, up 1/2. And so let's find the slope of that radius there. So it's going to be, so the slope is going to be let me say tangent pi over 6 is going to equal to rise over run 1/2 over root 3 over 2. Okay, and that's going to be those 1/2 times what, 2 over root 3. Okay, and that's going to equal the 2's are going to cancel 1 over root 3. To rationalize the denominator, root 3 over root 3, and so that is going to equal root 3 over 3. Okay, so the inverse tangent of root 3 over 3 is going to equal pi over 6. And again, I really like thinking of it as the arc tangent of root 3 over 3. That is, give me the arc on the circle where the slope is root 3 over 3. So it's going to be that arc there, of an arc length of pi over 6. Okay? How are we looking here? 6:14. We have plenty of time. Let's jump here and see if we covered these. I don't believe we covered all of them. Number 1, the inverse tangent of 0. Alright, again, the inverse tangent is keeping me over here. So when is the tangent 0? That is going to be, when is the slope 0? That's there, so that equals 0. Number 2, inverse tangent of 1. So let's draw my circle. Again, remind you that the inverse tangent is going to keep you over here. And when is the slope equal to 1? Well, we know the slope equals 1 there at theta equals pi over 4. Okay. Value of the inverse tangent of root 3. Number 3 is going to be inverse tangent of root 3. Again, I'm going to say or the arctan. Arctan of root 3. I really like this notation here because it says give me the arc where the tangent is root 3, or give me the arc where the slope of the radii is root 3. So, and we know that the arc has to be between negative pi over 2 and pi over 2. So let's think of it here. I want to know the arc where my slope is root 3, and that's going to be up there. Okay, so we have the inverse tangent of root 3 equals pi over 3. So one more example here. Sketch the radius of the unit circles corresponding to the angle inverse tangent of negative 3. So let's draw a circle for this one. Up there. How are we looking? We're looking good on time. Okay, and I need an angle that has a slope, and this is nothing exact. This is one of those questions where it's do you get it? Okay? So let me just say that here that the slope here would be a negative 1. So to get this question right on a test to demonstrate that you understand this concept, you just have to get somewhere down here, a little bit, just a little south of negative 1 to give you there on that red line. We're going to have a slope. The inverse tangent is negative 3. That is the slope m. The slope m equals negative 3, or is approximately equal to. I just freehanded it. Okay. What about inverse tangent? Let's say inverse tangent of 99. Does that exist? Do we have a slope of 99? Well, of course we do, because we can get, as we move toward pi over 2, we can get our slope as big as we want. So to get a problem like that correct to demonstrate you understand the learning target, you want to do something of that nature there, and that is going to have a slope m equals, or approximately equal to 99. Probably would actually be a little steeper than that. But anyway, that would be sufficient for demonstrating that you understand the concept. Okay? See you in the next video where I'm going to talk about an application of this. We're going back to the treehouse. Peace.